Alrighty then, corn children, children of the corn. It is a fine day for mathematics, and today we are going to put the fun in functions. This is a little tricky. Stay with it. I think you'll get it. Alright, I'm going to give you the definition. You're going to want to pause the video and copy it down, then we'll chat. Boom! Pause that video, write that down. Okay, I'm assuming that you have obeyed me and you have paused the video and you wrote it down. Let's walk through it. A function is a relationship between two variables, input and output. So we have two variables or numbers that go in, and as a result, numbers that come out. But there's a rule. Each input is assigned exactly one output. If you put a number in, it only has one answer. Let's try to make some sense of this with a little picture. Yeah. So what I've drawn is a function machine. Yes, it's a little box, and you'll notice on the top there's a little door where I can drop a number in. This would be where you put the input. Now, when you drop a number in, the machine goes to work. And it spits the answer out. Now, let's play pretend and let's have this be a function machine. Not just any old relation, but a function. So I get up in the morning and I decide to put 6 into the machine and it goes to work. And it spits out a 10. You don't know. Maybe it's just adding numbers. Who knows? I didn't tell you what's happening inside of here. I know if you put in a 6, out came a 10. Now, in order to represent this, we often will call the input variable the x's and the output are the y's. And I could make a little table. I put 6 in and out came 10. Now here's the key. If you are a function and I come to this function machine later in the day and I put 6 into the machine again, it cannot change its mind and give me a different answer. It needs to stick with the answer of 10. Now, if I put in a different number, let's say I put in 4 into the machine. Now that's a different input. It might get a different answer than 6. But here's the key. If you put 4 back in, it cannot change its mind and say the answer is sometimes 7 and sometimes 8. Each input gets one answer. 6 is assigned the answer of 10. 4 is assigned the answer of 7. This would be a small example of something that is a function. Now let's break the rule and see if we can find an example of something that is not a function. Well, I've drawn us another little machine, and in this little machine, it is not going to be a function. So I still have inputs. Those are our x's usually. And I'm still going to have outputs. And these are typically called the y. Not always, but usually. And we're going to keep track of some x's and y's. So I get up in the morning and I drop 10 into the machine. Okay. And in the morning, it says that the answer is 3. But I then later in the day come back and I again put 10 into the machine, but this time it says the answer with 10 is 7. It has changed its mind. This is not a function because one number put in, the number 10, has been given two different answers. This is not a function. Interesting. I wonder if we could see if something is a function or not a function if we look at a graph. After all, we could graph the point 10, 3, we could graph the point 10, 7, and we could look at them. Okay, I'm glad you asked. Let's do that. I'm going to show you the picture of a graph. Here we go. Let's take a look at this one. Okay, there's a graph. Now we need to see if when we put an X in, an input in, if there are two different answers that came out. Take a look right here. I have a dot here at the value 1, 1. I went right 1, up 1. I have a question. Do you see a dot at 1 comma something not 1? A different answer? Is there, for example, a point on our graph at 1, 5? Well, no. What about 1, 7? No. When X is 1, there is only one dot that far over. What about some other places? This is the dot 2, 4. The input is 2 and the output is 4. Do you see another dot on our graph that is 2, not 4? Well, X is 2, I go right 2. Is there a dot above this or below this? No. No, I do not see another dot. As a matter of fact, at each of these dots, there is only one dot that far over. This, ladies and gentlemen, is a function. Maybe we could look at an example of something that is not a function. Check this one out. I think it'll become clear. Okay, here's another graph. It's a lovely little graph, but I'm noticing something right away. I have a dot here at 1, 1, meaning 1 was filled in and a 1 came out. But later in the day, 1 was filled in and -1 came out. That's breaking our rule that says for every one input, you have one answer that comes out. This is two different answers. Look over here. Here, 4 was filled into the function. This is your in. And 2 came out. However, later in the day, someone put 4 back into the function and a different answer came out. Now, there's a fast way to see if something is not a function when you have a graph. It's called the vertical line test. If I put a vertical line through my graph, and if it touches more than once, meaning if it touches twice or 3 times or 4 times, if it touches more than once, it is not a function. Check it out. Here's another reason why. Oh, there's a vertical line and it touches more than once. Go back to the other example with me. I said that this one is a function. If I put any vertical line I want, touches just once. Oh, here's another vertical line. It touches just once. Here's another vertical line. It touches just once. Are there any vertical lines that are going to touch more than once? No, that's because it is a function.